In this tutorial, we're going to create a faucet using Solidworks xShape, a cloud-based subdivision tool for freeform 3D modeling. The following topics will be included in this workflow. You can find what you need to get started and design along with us using the link in the description below. In the Start file, you'll find we have 3 ordered geometrical sets, or OGSs. There are 2 hidden OGSs called Reference and Faucet Sample, which won't be needed until later. We'll begin our design in the currently active OGS called Start. Let's begin by inserting a cylinder primitive shape and dropping it on the origin marked by the X at the center of the model. We'll adjust the number of Z segments to 10. We can enable the Crease Edges option and use the Scale by Bounding Box option to set the width to be 40 millimeters. If we enable the Scale Non-Uniform option, we can also make the height of this cylinder 400. Click the green check to accept and continue. Focusing on the lower portion of the cylinder, let's build out the faucet base. We'll select the lowest vertical edge, and from the context toolbar, choose the Insert Loops command. To adjust multiple loops, we'll set our selection filter to Edge Loops. We can now select the entire loop of edges by clicking a single edge. Notice that our selection filter reverts back to any entities. If we want to keep selecting more edge loops, we can click the pin next to the option. If we then hold the Control key, we can add this loop to our selection, and from the context toolbar, we can add a crease to these edges. With this selection still active, let's click the arrow to expose the ruler, and then click and drag up by 30 millimeters. Now let's select the lower of the 2 loops to translate it further up, but this time we'll click on the number 0 so we can type in our precise value of 10 millimeters. We'll return to our selection filters and pin the Any Entities option. Let's now box select the lowest 2 loops of vertices. We can deactivate the robot by clicking the center. Now we can click, drag, and drop the robot onto a vertex. Note that if the planes get in the way, they can be hidden from the V key shortcut menu. Click the center of the robot once again to reactivate it, and then right-click on it to reorient to XYZ. Hold on the Alt key while clicking and dragging one of the scale points to scale in all directions. Note that we are scaling relative to the new position of the robot, and we'll scale until we end up with roughly a 45-degree chamfer. Let's now box select the lowest 3 loops of vertices and enable the Working Zone option. The Working Zone isolates our selected vertices, so no other vertices can be edited. The Invert Selection option gives us the result we're looking for. Next, we want to add a taper to our cylinder, so we can use another mode of modeling called Soft Selection. Soft Selection extends the influence of the robot by an adjustable radius. With the default settings, we can box select the 5th loop of vertices from the top. Notice the colors applied to the surrounding vertices. The red-colored vertices experience the effect the most, whereas the blue experiences the least. To scale in 2 directions, we'll click and release one scale point, then click and drag another, and we'll scale this down slightly. We can set the range of influence by distance from our selection or by number of faces away. Let's set this to 5. The fall-off parameter allows us to define how the influence graduates across the radius of influence. Let's set the fall-off to concave and continue scaling down in both directions. And feel free to continue experimenting in this mode. Now it's time to bend this faucet into shape from the side view, specifically the ZX direction as shown in the orientation triad. Let's launch the Arc Bend command from the action bar. The Arc Bend tool includes an arc and a bend line that we can adjust. Click and drag the ring of the endpoints to position the line like shown. When we box select the top 5 loops of vertices, they will snap to the bend line. We can click and drag the endpoint to bend it around. Note the Limit Bend option that allows us to apply the bend only to the arc portion of our selection. For this workflow, we'll use a normal bend. We now have a good starting point for trying out different concepts, but we want to have this version of our surface to fall back on later, so we can exit the subdivision environment and use ordered geometrical sets to organize our concepts. Let's hide the Start OGS and then show the Faucet sample OGS. Let's move on and click on the 3D shape to launch the Insert Ordered Geometrical Set command from the Context toolbar. Slow double-click to rename this New Concept. We'll now right-click on the initial sub-D surface we created and click Copy. Then paste it into our new OGS using the Ctrl-V keyboard shortcut. Pasting the sub-D gives us options to insert it anywhere in the graphics area, or we can snap it to its centroid. Note the option to scale the pasted sub-D surface as well. Accepting this brings us into the sub-D environment with our new pasted body. Now we can right-click to hide the sample faucet. In our new concept, we only want to affect the base where we'll create a handle. So we can turn off the working zone in the top right corner, box select the lowest 3 loops, and then turn the working zone back on. Let's launch the Insert Loops command from the action bar so we get the option to insert more than one loop. Let's set this to 3 loops and continue. We'll hold on the Control key while clicking the 4 central faces on the side of our sink. And from the Context toolbar, we'll select the Extrude command to start building out the handle of the faucet. We'll hold the Control key again to select these faces and add a crease. Without changing our selection, we can edit the working zone from the Context toolbar. We'll go to a front view and box select the vertices on the base to remove them. Keep in mind that adjusting the vertices at the boundary of the working zone may affect the adjacent vertices outside the working zone. Let's show our reference OGS, which has a plane and a couple setup sketches included. We'll first box select the active entities and hold the Control key while we click the plane. We can choose the Align to Geometry command from the Context toolbar. Now we'll select one of the creased edges and choose the Tangent Propagation option. We can hold the Control key while we click the circular sketch, and from the Context toolbar we can choose Align to Curve. The vertices don't match perfectly, but if we expand the dialog box, we can enable the Even Vertex Distribution option. You may notice that the resulting edges are smaller than our circle. Let's turn on the Cage view to better understand this. The Cage view is the mesh from which the sub-D surface is generated, so when we align the vertices to a curve like this circle, we can see the vertices in the Cage view are what actually get aligned. Now that we're done with the reference OGS, we can hide it. We're left with a nearly perfect mesh except for the central vertex. To align this vertex, let's hold the Control key while selecting these 2 outer vertices first, and then the central vertex last. From the Context toolbar, we can choose the Align Vertices to Each Other option. The order of selection is important because the first 2 vertices selected are used to define an imaginary line to which all other selected entities are aligned. Now let's select one of the faces and choose Tangent Propagation from the Context toolbar. Launching the Subdivide command from the action bar gives us a scaling point that we can click and drag to adjust the size of the subdivided faces. Let's select the 4 innermost faces while holding the Control key and translate these faces out in the normal direction by 10 mm. With the selection still active, we'll choose the Extrude command from the Context toolbar. Let's select these 4 faces while holding the Control key and then rotate them down by 20 degrees. Next, we'll select this edge and choose the Insert Loops command from the Context toolbar. we can double-click our new edge to select the entire loop. Let's hold the Alt key while clicking and dragging one of the scale points to increase the size of the loop slightly. Now let's hold the Control key while we select the top two faces and choose the Extrude command from the context toolbar. To align the front faces, we'll select this face first, then hold the Control key while we click the two new front faces. Choosing the Align Colinear option aligns everything selected to the face that was selected first. We'll now select one of these faces and hold the Control key while we select the rear two faces, and this time we'll choose the Align Parallel command. We then need to select these faces using the Control key again and translate them in the normal direction by about 3 millimeters. To straighten out the side edges, let's hold the Control key while we select the two outer edges and then select the middle one last. Choosing Align Coincident finds the average of the first two selected edges or faces, then aligns the entire selection to said average. We'll repeat this step for the other side. Now let's select the top two faces while holding the Control key. We can right-click on the center of the robot to reorient it to XYZ, and then click the arrow pointing in the Z direction. We can click to type in an exact value of 40 millimeters. And we'll use the Insert Loops command from the action bar to add 2 more loops along the length of our handle. Let's exit the cage view and then select the outer faces of the handle. Let's click this one and hold the Shift key while selecting the upper half of this face, then the left half of this face, and finally the lower half of this face. From the context toolbar, we can add a crease. To add some curvature to our handle, let's launch Soft Selection again. We can adjust the settings so we affect 4 faces away from our selection with a linear fall-off. We'll box select the top vertices and scale them down in the X direction. For some final touches, we will select these 3 edges using the Shift key and translate them out by about 1 millimeter or so. We'll also translate these rear 4 faces in by a few millimeters to thin out the handle. Once we're satisfied with this design, we can exit the Sub-D environment. If we'd like to, we could keep tinkering with these concepts or start a new one in its own OGS. To check the behavior of our final surface, we can go to the Tools tab of the action bar and enable the Zebra Stripes analysis. These zebra stripes allow us to visualize the surface behavior, and we can adjust the parameters of the analysis. Keep in mind that you can have zebra stripes on when you're modeling in the Sub-D environment. Feel free to continue modeling and make this design your own. And if you'd like to see more tutorials, check out the Solidworks YouTube channel.